And we'll say, good morning. Sounds like you can hear me in the back okay? All right. So, couple announcements as we get started today. First of all, as I sent out an email maybe about 2 hours ago, several of you had reported there were issues submitting your homework 6 to Blackboard. If you tried again this morning, were you able to get it submitted, or were you still having issues? Everything's good? Okay. Did anybody then this morning have any issues submitting things to Blackboard? Okay, then we're just going to call it good. What sometimes happens, someone in some class will upload a really large file and it just clogs one of the Blackboard servers, which, depending on, there's about 6 different login servers. If you're on that specific one, you'll have a problem, but then if you're on a different one, it takes them like 30 seconds to clear it out. They just have to know there's a problem. So hopefully that won't happen again for any of the other assignments, frankly. I'm amazed that this is the first time it's happened this semester. Usually happens at least 2 or 3 times. But anyway, so then I will post solutions to that homework assignment shortly after class today. Remember that we have our quiz on the search engines unit then on Wednesday at the end of lecture, so the normal time around 9:30. And then also remember that your term paper final draft is due by the end of the day on Wednesday. Okay? I'm going to make one note that I probably don't need to make to anyone sitting here in the room, but maybe someone listening at home on the audio might want to hear it, and I'll say it anyway. Mostly because I had a problem with this in my calculus class over the weekend. I am really good at finding plagiarism. Do not turn in a plagiarized paper. You have been warned. I turned in 5% of my calc class over this weekend for cheating on their exam last week. It's not fun. Please don't make me do it. Okay? With that being said, does anybody have any questions? Yep.
Are we supposed to be able to see the grades that people gave us?
You should be able to see them. So if you go to the same portal where you submitted your first draft, where you submitted your reviews, it should now, if you click on that, it should give you the reviews that people gave to you.
It did on the first day, but then it said grades not available.
Oh, okay, I can fix that. That's probably because this is where Blackboard is weird. So I went to try to hide the column in the grade center. That way it's not showing because we haven't done anything with it yet, but that probably just obscured all of the visibility. I apologize for that, and give me 20 seconds after class, I can fix that. Yep, and the paper will be submitted online. So in that term paper folder in the assignments page, there's now a submission portal for final draft. Yep, and submit it there just like you would a homework assignment. Just upload your PDF. There's no issue. If you want your paper to be anonymous, that's fine. It doesn't have to be. Again, we will know through Blackboard that you submitted it. If you don't want to go put your name and all that in it, that's fine. It doesn't matter on this case. But we'll get those submitted on Wednesday. It's going to take us a little while to get them graded, so it may not be until the final week of class that you actually see the grades. And again, we'll do the whole term paper dump all at the same time, talking about what the first draft was, all of the process, because we pretty much grade all of that together in one fell swoop. So I know it's been a couple weeks since some of that was turned in, and there's not many grades posted. They will all get posted, but probably like that last week of class.
So for the page limit on the paper, is that like 5 pages of text, or is that 5 pages total, including references?
So it's 5 pages of text and figures. Okay. References do not count towards the 5-page limit. Okay. And just a note on references, also just a reminder, as I was sort of skimming through some people's first drafts and as people were coming to talk to me at office hours, remember to be using in-text citations. So, you have your work cited at the end of the list, but it's okay to just, say, well, it's either, depending on how you number it, it's either reference 1 or reference, here's the author and the year. Make sure you've got in-text citations throughout your document saying, here's where that information came from, and especially on the images. If you took an image or a figure from a place, make sure in your figure caption you say where it came from. Okay, those are important details. Yep.
I forget, if you have like 2 to 3 sentences that you like paraphrase, do you put a citation after every sentence?
Just put it at the end of the block. I sort of think of it as it's per usage of the document. There's one citation. If it takes 2 or 3 sentences, but it's sort of the same idea, that I'm not going to get hung up on that.
So pretty much after me giving a term paper and you graded like the whole basic thing, we should know how we're looking for like the end of semester.
Yeah, so the goal that I'm going to have, so thinking ahead to the end of the semester, realizing that that's only about 3 weeks out. Okay, we're getting very near. The last day of class, it is my goal, and certainly David and I will be working towards this, is that that last day of class, everything will be graded. We will have everything to return to you. Your term papers will be handed back at that point. All of the last quiz for the Google Maps unit that we're in right now, plus anything that you haven't picked up, we will bring, and I will post to Blackboard. Again, this is the goal. It may not happen. And the final exam for this class is late in finals period, so it's not like there's a timing issue involved here. But the goal is that coming into that class, I will post on Blackboard what your grade is, assuming you choose not to take the final. That way you can then decide whether you want to stick around to the bloody end of finals week to take this exam or not. But that's the goal for sort of that last day of class. And so everything will be posted around that time.
You said hand this back to somebody immediately, you're just going to give us a grade, right?
Yeah, so I'm going to print off basically the rubric for everyone, and as I'm grading it, it'll be sort of some comments on there for people. So I'm not going to actually print out your term paper, but there'll be sort of a little sheet of comments and how it was scored. Yep. Other questions relating to anything? I know a few people asked last week about number 3 on the quiz that was just handed back. Do we want to discuss that briefly? Okay, so the idea here, so the question was, when setting up kidney exchanges from a registry, why do we need cycles to be disjoint? Okay, so one of the big themes from that unit, okay, we have to think back to the organ donation unit, I know that was a little while ago, was we were looking to set up cycles in our graph because any one of those cycles would be a way to then set up how to actually do the kidney exchanges. So, person A in the cycle gives to pair B, gives to pair C, that gives back to pair A. Everyone gets a kidney, everyone gives a kidney, everything's good. What does it mean? So the key word in this sentence was then that the cycles need to be disjoint. What does disjoint mean? Well, I'm sorry? Unconnected. So if we have multiple cycles, so suppose we have a really big set of donors and acceptors, and we're looking what's the way to sort of match people up to get the most number of the most number of kidneys into people that need them. We're just looking to say how many pairs can we get in these cycles. But when we say disjoint cycles, they have to be unconnected. We can't have one particular donor acceptor pair used in 2 cycles. Why can't we let that happen? Why can't the same sort of donor give 2 kidneys? Because then they would need a kidney, and that sort of defeats the whole purpose of this procedure. So the idea of those disjoint cycles is, when we were looking at that graph, what that's telling us are all of the possible connections that we could make when trying to figure out how to give kidneys to people. When we're looking for identifying those cycles, now we're saying, now we're going to make a plan, and here's what we're actually going to do, but any one given acceptor can only give 1 kidney, so they can only be in 1 cycle. And so we needed a set of disjoint cycles that would then be allowed to set up and figure out how do we actually get the kidneys from one person to another and save the most number of lives. Okay? Does that make sense? So we talked about that. That was sort of in the slides in the last day when we were going through those big examples. I was not certainly intending for that question to be necessarily as brutal as it turned out to be. But life goes on. Okay? Other questions about anything before we jump in? Okay. If not, then like I said, I will post solutions to homework 6 shortly after class, and I will fix that so that you can view the reviews. If it gets to be about like 1 o'clock this afternoon, and for whatever reason I've just gotten busy and I forgot to do it, just someone send me an email. I will take care of it. I apologize for any inconvenience or any hassle. So, then what we're going to do today is sort of pick back up with our discussion. So last time we finished our search engines unit, and we started talking about, what was the next technology? We started talking about Google Maps. And so in particular, we started at sort of asking, well, what do we use Google Maps for? Again, what's the societal context for this technology? And we had lots of examples. We talked about this quite a bit last time. Just to do a brief recap, I know it's been 5 days since we thought about this. But we can use Google Maps to find places, to get directions. Some of us have used it to locate traffic jams. I'm sure more than some of us have used it for that. If you're into exercise, planning, runs, hikes, bike rides, etc. We looked at Street View a little bit, and actually I think we used the Bean in Chicago to actually see how Street View works, where you can sort of see at sort of the ground level what everything looks like. But there's all this information in Google Maps. And the key idea now, and one of the reasons why we've now saved this unit till the very end of the semester, is that in some sense Google Maps is basically a search engine for geographical data. Whether you're just trying to find what is the place, what are restaurants around here, how do I get from point A to point B, these are all queries you could ask of this catalog of geographical information that then Google Maps can try to give you a response, just as much as Google was just a search engine more for information. And so we saw some examples. We can look at overlays. Besides just getting directions and looking at places, Google Maps actually allows you to do overlays to look at different regions. And so we could see maybe municipal regions like Stony Brook, New York, sketched out on the map. You can see more sort of artificial or political divisions. This is the New York 1 House District in the U.S. House of Representatives. Again, Stony Brook marked with the little blue dot there. These regions don't have to be simple. They can be quite complicated in shape, as seen by some gerrymandered congressional districts in North Carolina. And then other things that we can do, there's different views. We can actually start to look at these terrain and satellite view, not just the street-wise things, or the street views, which is a different thing entirely, but like just looking at sort of the map and here's the streets and the intersections. And of course, Google will label it. You can see there's the Chrysler Building sort of right in here. Public transit information is superimposed on it, Grand Central Station. Can actually look at some of the satellite imagery where Google's going to try to do parallax, where it's got several different images of this region, and try to give you a 3D representation of what some of the stuff looks like, which, when this first came out, I really thought this looked like something straight out of SimCity. I mean, I'm probably not the only one that thinks that. But it's pretty cool to explore around the world. Over the weekend, did anybody go looking at Google Maps or play with any of these tools and find something fun? Was there some part of the world you were able to explore that had some neat images? Yeah.
When I use Google Maps, specifically I use Google Earth,
Mm-hmm.
and it generates a similar 3D image.
Right.
And apparently their latest update includes the car outside my house.
Interesting.
So I can actually see my car going down to like street view.
Okay, well, that's pretty cool. So just to reiterate on the mic so maybe everyone can hear it. So you're using Google Earth, which is sort of just a different way of accessing this Google Maps database and catalog of information. But apparently they came through and took new photos recently, and you can see your car parked at your driveway. Okay. So now we can all find out your license plate number and what you drive. Cool. So you can find neat things like that. Also, some of these features can sometimes be disabled. As we saw looking at the White House, if you try to go and look at that 3D view, it will not actually bring it up. It just keeps it sort of plastered down on the 2D for security reasons. And there are other, certainly federal and state buildings in this country where this happens, as well as certain things internationally. Downing Street in London probably has the same effect. If you try to go view that 3D, it's just going to keep Downing Street nice and flat, just to try to prevent people from getting information that they don't necessarily need for security reasons. So, coming into some new stuff, again, thinking back towards the history, what did we do before Google Maps? How would you access all of this geographical information? How would you search it to try to figure out how do I get from point A to point B, or what's around? What would you do? Okay, so we could actually have an actual folding map. Anybody played that game before? Where you've unfolded it and then you need to fold it back down, and it never works. Never, ever works. Okay, so that can be really useful for finding directions, but only if maybe this folding map covers all of your area. If you're trying to drive from New York City to Los Angeles, is a folding map of the New York City metro area really going to be all that helpful? I mean, maybe in the beginning, in terms of how do I get out of here, but then once you probably cross the Hudson River, is it going to be useful? Not really. So maybe one of the limitations is you had to have a whole bunch of folding maps. Or you might have something a little bit more general, like one of these road atlases. They still actually make these things. I know that one is dated 2016, but you can still go to like a gas station and buy a print copy of the road atlas. I'm not really aware of anyone under 65 that does that, but I'm sure you could find someone. That sounds like something I would do. Okay, we also have, does anybody remember the old website MapQuest? Okay, did anybody ever use MapQuest? Okay, there are a couple of hands. So Google Maps has basically killed MapQuest at this point. But for years, that was really the way to do it. And what were some of the limitations of MapQuest?
While you were driving, you had to get the directions absolutely right because MapQuest wouldn't be able to correct you.
Okay, so MapQuest didn't really have this autocorrect where if you missed a turn where then it would say recalculating in some snobby voice and make you feel a little bit stupid and then give you new directions. Well, yeah, so you had to follow the directions rigidly. And one of the other reasons for that is MapQuest wasn't interfaced to your phone in a lot of cases. So MapQuest was a really useful website, but you had to have a dedicated computer with an internet connection to use it. So as you're driving, you had to sort of plan ahead and say, oh, I know I'm going to need these directions, go to MapQuest, and print them out. And you'd have them in your car, and then if you get lost, you're screwed. Okay. Was it better than maybe just having the road atlas, and was it helpful? Sure. Was it as useful as Google Maps is now? No. And that's why it's not really a thing anymore. Okay. What are some other tools that you might have used before Google Maps for doing any of these tasks that Google Maps can now do for you? Okay, so right, so if you wanted to know traffic updates, maybe you would look at the news in the morning, or you're listening to some AM band radio that's giving you the, I don't know, traffic on the 10s or whatever it may be. But you could think about, so here's a screenshot of News 12, showing this has to be taken on a Sunday morning. I don't think News 12 ever shows everything that green. But the idea of you can get traffic reports, there were ways to do that. And also, at the same time, sort of looking at the news or the radio, you could get construction information, accident information, things like that, that might help you change your route. But in the event that, you know, you did find this information, was it good at telling you what an alternate was? All you know is, oh, I shouldn't get on the LIE, which is probably good advice anyway. But what would you take as an alternative? Well, there's some other green lines. You should pick one. Okay. Something else, I don't know, this might be dating myself, but maybe you had a cell phone in the car and you called someone at home to be like, hey, I'm stuck in traffic. Can you find me an alternate route? And they boot up their computer and you wait 30 seconds and you hear the awful screeching modem sound. Anybody remember the awful screeching modem sound? Okay. And then 10 minutes later, after their internet web page loads at the 56K connection, they're able to tell you, oh, get off the road. You think, I'm already past the traffic jam. This wasn't useful. Anybody have that happen? Okay. So there were lots of different ways to go about getting this information. Not all of them great, but they were there. And it's really sort of impressive to me to think that Google Maps can now basically do all of these things in one. Not to mention, like if you wanted to know the actual city municipal boundaries or something, or do some of those other features, like look at the overlays, what would you do? Probably go to like some city hall or some library and actually look at it. Most atlases wouldn't necessarily show those. Again, if you wanted to go do exercising or something and you want to know what's a good running route, is News 12 going to help with that? No. Not at all. What do you? Ask a friend. Okay. So there are all sorts of different things that Google Maps has brought together even beyond that. What about Street View? Were there any alternatives to Street View where you wanted to know, oh, what's on this street and what does it look like before Google Maps? Yeah, it was called Walk Down the Street. Take a look. Remember things. Oh, no. All right. So one of the questions that we're going to turn to for the next couple minutes or so is trying to get this question, so what goes into Google Maps, or in some sense, how did they build it? So now we have this phenomenal tool of all of this geographical information. Where did it come from? So it's sort of akin to, when we started talking about search engines, before you can go to Google and say, I want to know about cat videos, Google has to know what's out there. And we had all these spiders. So how did Google build this big database of geographic information? There are two really nice articles here. We're going to discuss these in class, and a lot of the pictures that we're going to have in subsequent slides came from one of these two articles from either The Atlantic or Wired magazine, talking about some of the tools that go underneath this. Now, certainly these articles do not tell you everything, and why not? It's proprietary. Does Google want you knowing exactly how they built Google Maps? No, because then you would go build your own version of Google Maps. So we'd have Map Maps, and then I would charge a fee, and no one would use it because Google Maps is free, and I'd go out of business really quickly, but they don't even want that happening. Okay? So there's certain pieces of information, and these are really interesting reads, and some of the visuals are fantastic in them. So I would encourage you to go look at them. We're not going to talk about every detail from them here in class. But there's some neat stuff that goes in. And so what this really amounts to then, if we think about Google Maps as the search engine, what we're now starting to deal with are these first two steps back from our search engine algorithm of how do we do the indexing and the cataloging. How do we go through and figure out what is all of this information, and then how do we store all of it so that when someone actually puts in a query, we can perform that query and make recommendations. Where is Kentucky Fried Chicken close to here? I don't know. But Google Maps could probably tell us. So one of the first things we have to think about then, if we're talking about Google Maps, is how do we build maps? Okay, this sounds like a really 14th century style question. And perhaps it is. Okay. And so in this sense, we get to cartography, which is the study and practice of making maps. And so this is sort of a pedantic issue that needs to maybe get a little bit resolved before we go on. But how do we make maps of the Earth's surface? Anybody? Is that even a good question to ask?
You mean in modern times or like?
Modern or historical? Let's talk about both.
Well, modern times probably satellite.
Okay, so modern day, we probably use some sort of satellite imagery to construct this, because we all know the Earth is flat. Remember, the Flat Earth Society exists all around the globe. That was a joke. 'Cause if the flat Earth all around the... Anyway. Okay, so we've got maybe satellite imagery. In maybe more historical times, what was used to make maps?
People would literally go out to the areas they were mapping, and they would like, lose the bar, for example, they would literally walk through the wilderness, and they would take note of everything.
Yeah. So they might just actually walk through, or if it's in water, sort of sail through someplace, make note, and they'd have some instruments, like they'd have compasses, maybe sextants and things like this, to try to do geometry calculations at the time, and then try to basically draw by hand what they think the map would look like. And so if you go back and see any sort of 18th or 19th century maps, particularly of like the New World when they're exploring North America, you know, especially like the Great Lakes is a fascinating region where no one got the lakes right. If you look at a map of Michigan back in like the 1900s or 1800s, 1700s, it's terrible. There's an upper peninsula, there's a lower peninsula, and everything is skewed. They're bad. But that was sort of the best you could do at the time. And certainly satellite images have given us a bunch of more power. But there's a bigger issue that we have to get into is sort of then asking ourselves, so the idea of making a map now, so we have the surface of the Earth. We've got this, again, we'll assume the Earth is a sphere. And when we want to turn it into a map, we're taking the surface of that sphere and we're doing what to it? We're putting it onto a flat screen or a sheet of paper. A proof that is certainly more than we need to go into in this class, but we'll have a fun visual aid here in a moment. Is it possible mathematically to take the surface of the sphere and put it flat onto like the flat of the table or a sheet of paper or a screen? Is that something that's even possible to do? Okay, I hear the answer yes. Does anybody else want to go with yes? Anybody want to go with no? Okay, well, let's pull out an example where we will approximate the surface of the Earth. Well, that's not going to work. Anyone have any tape? Okay, so pretend this balloon did not have a hole in it. That's delightful. The things you should check for before you do these examples. Okay, so pretend we now have this big inflated balloon. Okay, and we'll say it's kind of like a sphere. All right? If we were to take it, you know, does the sphere sort of just lay flat on the surface? No, it doesn't. Okay, so suppose now we were to go in. This is where we can have fun with the balloon. And it's funny they say it was already sort of cut and had a hole, because what was I going to do? Slice it open. So we can cut this sphere open, sort of just take a cut down the side of this balloon. Of course, I have a dull pair of scissors too. Happy Monday. Okay, and so we now have our balloon sliced open, and so we've got sort of, it opens up into two halves. Ooh, there were two holes in the balloon. Okay, and we put this down. Does that lay flat on the surface? If I hit it a couple times, does it lay flat on the surface? Not really. I mean, there's still sort of, it wrinkles and it crinkles, but it doesn't really sort of just nicely lay on the surface. Is there anything I can do to make these two halves of the balloon lay flat on the surface? If I really stretch it out, will it lay flat? No, it's just going to rip in half because it was already ripped. Okay? So one of the things and one of the issues we have to deal with is the fact that it turns out there is no way to actually take the surface of a sphere and make it completely flat. It's not possible. But yet we know we have all of these maps. We can look up an atlas. We can go to Google Maps. So what happens? What gives? If it's not mathematically possible, why do these things exist? Anybody have an idea or have a guess?
Well, like
Okay, so maybe we can alter some of the distances a little bit. So there's a couple things that go on. One of the bigger answer is we can always do it if we allow distortion. So there's sort of two geometric things that we usually are very interested in maps. Is we want to know what are the distances between 2 points and what are angles. Okay, so on the globe, latitude and longitude, what's the angle between any line of latitude and any line of longitude? It's 90 degrees. If we were to now take this globe and try to put it on a sheet of paper, when we talk about distortion, if we draw latitude lines, we draw longitude lines, might they be 90 degrees? Yes. Are we going to require them to be 90 degrees? Maybe not. So we can distort those angles. Okay? Could we also maybe distort distances a little bit? You know, think about taking that balloon where it doesn't lay flat, but if we stretch it out a bit, well then things near the center are probably right, but things out towards the edge might be a little bit crazy. But is that something we could maybe do that then sort of gives us the approximation that it's laying flat on the surface? Absolutely. And so this is what it basically boils down to, is how do we introduce this distortion? And in some cases, maybe we want a map that's really good at preserving angles. Can we find a way to do that? Sure. Maybe instead we want a map that's really good at preserving distances. Can we do that? Yes. There's usually a trade-off. The more accuracy you have on distances, the worse your angles are going to be. The better your angles are, the worse your distances are going to be. What usually happens on what people consider to be, quote, good, unquote, maps is there's some sort of trade-off between the two. One of the other things that works well and works to our favor is if we're not going to consider the entirety of the globe of the Earth, but maybe we're only going to look at some small part of it. So I don't know, maybe we look at Long Island. Is the Earth relatively flat over some small segment of its surface? If we go outside, we weren't sitting in this building right now, and we look around, does the Earth look to be flat as we sort of just, look all around us? Yeah. So we could maybe over small distances basically assume that it is flat. Because again, when the radius of the Earth is about 4,000 miles, if we're talking 500 feet in some direction, you can probably approximate that as a flat surface with almost no issue. Okay? So maybe we can use that to our benefit as well. The fact that the Earth is really big, and in some small area, it's flat. Okay. So basically what this boils down to is we have to come back to some geometry. And in particular, we can think about this math concept called a projection. And so, as we've already said, it is not possible to faithfully put the surface of a sphere onto a sheet of paper or a computer screen. And by faithful, what do you think we mean by the word faithful in that sentence? A faithful projection would keep angles and distances completely unchanged. So we would look at our map and say, every latitude and longitude line meets at a 90-degree angle, and the distances are preserved. If it's I don't know, 2,000 or 2,500 miles from here to LA, and it's 2,500 miles from here to Vancouver, then those distances are going to look to be about the same on the map. Okay? And as we know, as we've already said, it is not possible to make a faithful representation of the entire surface of the Earth. So what do? We make different projections. And so there's a bit to be said here, just as a few ways. Number one, there's no unique projection. So I'm sure as you've gone through your education and you've looked at different geography textbooks, you've seen that maps sometimes look a little bit different from one picture to another because they're using different projections. That's not to say that one is better or worse than the other, although we will certainly pass judgment on some of them here momentarily. But they're just different ways of taking the projection. And so I put here, there's a few links. The U.S. Geological Survey has some nice information here with a whole bunch of different map projections. We'll see some of these figures here in a little bit. I know it's sort of an old website and everything's in black and white, but there's a lot of really neat information there. The other thing that we can see, there's this GIS Lounge, which is maybe a little bit more modern on it, and we can see some of these projections as well, and we'll see some of these pictures. But take a look over these if you're curious. If you think you know what the globe looks like and you've never really thought about projections, you might find it interesting. There's also, from the joking perspective, there's the XKCD of what's your favorite map projection. I kind of like the Dymaxion map projection. Waterman butterfly, there's other sorts of things you can look at, but this is just sort of a joke. But take a look on your own time. It's kind of funny if you're curious. And so one of the most standard map projections that we'll get is what's called the Mercator projection. And so the way that this works is we're going to think about now our sheet of paper where we're going to have our map. And it's going to be, think of it as some sheet of paper. Okay, so we want to draw our map somewhere on this. What we're going to do is we're going to curve the sheet of paper into a cylinder. And we're going to assume that it snugly fits the Earth along some circle. So we're going to have, pretend like my fist is the Earth. It's going to be in the middle of this sheet of paper, where the sheet of paper is basically coming up and exactly touching it around one great circle, one circumference of the Earth. Traditionally, when we think about the Mercator, the Mercator projection, what is that great circle going to be where we have the sheet of paper touch? Does anybody know? It's the equator, right? As sort of visualized here. And so the way this projection works is, think about now at the very center of the Earth, we're going to put a really big light bulb. Okay? So we turn on the light, and what we're now going to do is say, trace a line. So from the center of the Earth out through some point on the surface, and wherever that line hits this sheet of paper is where that particular point on the surface of the Earth will appear on our map. Okay? And so that's exactly sort of what we see here. On the equator, we'll notice our sheet of paper actually touches the Earth at the equator, so everything is sort of just nice and preserved, and we get that exact equator. As we move maybe north a little bit, so I don't know, maybe this is 30 degrees north latitude, we come up, and now is our sheet of paper actually touching the Earth at that point? No, it's a little ways away. So we're going to have this line coming from the center of the Earth. It's going to hit the surface maybe somewhere around here and have to go a little bit further to now hit our sheet of paper, that cylinder sort of wrapped around it. But we would see that we get something up here. And there's a certain distance now between here's the equator, here's 30 degrees. As we move further north, 60 degrees, what happens to that distance between the surface of the Earth and our sheet of the paper? It increases. Okay? So that means we have to go probably a little bit further up on the sheet of paper. And notice now we're starting to get some distortion, because this line here is our 0 degrees latitude, 30 degrees latitude, and let's say, I don't know, suppose that's 1 inch between those two. Now here's 30 degrees latitude, 60 degrees latitude. Is that still only 1 inch between them? No, that distance has actually increased quite a bit. Okay? And so we're starting to see now that distortion. Are angles preserved by the Mercator projection? Yeah, you'll notice that all of the latitude lines and all of the longitude lines form 90-degree angles with each other. So angles are completely preserved, and that's one of the reasons why the Mercator projection is used very commonly, is it's actually really good at angles. It's terrible at distances. And so one of the big conundra that come out of this, so here we have this shape here. What is this? Okay, we get Africa. We've got this thing up here, and it is Greenland. Based on this Mercator projection, what do you think about the relative sizes of Africa and Greenland? They look pretty close, like to say that Greenland is about the same size as Africa, based on this map projection. In reality, does anybody know off the top of your head, what is about the relative size of Greenland and Africa? Africa's way bigger. Africa's about 11 times bigger than Greenland. Okay? And is that even remotely reflected in this map? No. And so that's one of the limitations. If you're using the Mercator projection, be very careful when you start trying to interpret distances and sizes, especially when you get far away from that point where the map is actually touching the sphere. So near the equator, distances are probably okay. But as we get further and further and further away towards either the North or the South Pole, we start to get a lot of distortion in these maps. Okay? One other question that we might want to ask, was there anything special about the equator? When we were thinking about sort of curling up this cylinder and saying we're going to put it along one of those great circles, did we have to choose the equator? No. By convention, that's what's normally done, but we could choose any other great circle. And so you could think about making a Mercator projection where now let's choose the prime meridian international date line as our great circle. So now instead of the cylinder sort of being upright, it's going to sort of come out to the side. And we can make a Mercator projection in the same way, and this is actually what comes out. Does this map really even look recognizable to most of you? No, because you're so used to seeing the Mercator projection, or one of the ones we'll talk about momentarily. I mean, you would probably guess this is a map because that kind of looks like Africa. As it turns out, Africa is not far from the equator or the prime meridian. So there's not a lot of distortion. But, is South America here recognizable from what you usually see? No, I mean, you sort of see there's the Horn in Brazil, but this west side, because it's getting now farther and farther and farther away from that prime meridian international dateline, starts to have a huge amount of distortion on it. Likewise, is North America hardly recognizable here? Not really. Mexico certainly looks a little bit weird. US also looks sort of funky. But now, one thing to see, Greenland is pretty close to the prime meridian, as is Africa. Would we now guess that Greenland is about 1/11th the size of Africa? Yeah, because now they're closer to that great circle, so there's less distortion in that particular region. Do you have a question? Okay. So the idea here is, again, there's no unique map projection. And even within the same frame of how do we make a projection, there might be multiple ways to do it, and the map can look very different depending on what choice you make. So again, this is why I would encourage you. There's some really neat visuals buried in those web pages. If you think you know what the surface of the Earth looks like, brace yourself. Okay? So another one that's used, another standard, so the Robinson projection, which we've got here, and the Mercator projection around the equator are the two typical maps that you'll see. Robinson projection, how it's actually formed is a little bit more complicated, but the idea that Robinson had was to say, well, let's try to get rid of some of this distortion in sizes. And so sort of going back to this balance, Mercator said we're going to get angles exactly right, but we can now get some huge distortions as we get far away from the equator in the usual sense. Robinson said, well, let's soften the blow a little bit. What if we sort of let the angles have some distortion? But can we use that to maybe improve some of the distortion in the distances? And the answer was yes. And so he came up with what's now called the Robinson projection, where notice, close to the equator and the prime meridian here, do these latitude and longitude lines meet at a 90-degree angle? Sure, they're pretty good there. But as we move sort of away from those two, like up here sort of in the Pacific Northwest, is that a 90-degree angle between those latitude and longitude lines? Not even close. So we've introduced a little bit of distortion in our angles. But now what happened to our relative distances? There's still some distortion. Is Antarctica really this huge blob at the bottom end of the planet? No. I mean, we can go back a slide. Is Antarctica really that big? Not necessarily. Okay. So there's still some distortion. But does Greenland now look like it's the same size as Africa? No. It may not be 1/11th in this particular picture. I would say maybe more like a third, maybe a fourth. But the idea is there's less distortion. So there's always a trade-off when we're choosing these map projections. What is it we're looking for? If for our application we need really good distances, the Mercator projection is probably a bad map to choose. However, if we needed really good angles, the Mercator projection is probably a great map to choose. Okay? So again, it depends what you're trying to do and what you're using your map for. But the key idea is there's no unique way to do this. Okay, so sort of at the end of this pedantic discussion, back to Google Maps. So the issue now, does Google Maps only work in a local area, or is it sort of good all over the globe? It's good all over the globe. So how does it make this work? Because we've just said we can't actually have a faithful representation. Is Google Maps going to be okay if we get really good angles, but distances start to get distorted? Is that going to make Google Maps useful? Not even in the slightest. So how do they go about getting around this problem? Any ideas? What do you think Google Maps might do?
Well, first of all, they represent the Earth as a sphere. They don't represent it as like a flat surface.
Okay, so they could represent it as a sphere, certainly. That's one thing they might do underneath the scenes, but is that going to be useful when you go to get instructions and information? They're still going to display it on your smartphone, and do they give you the globe and sort of show it to you rotating around, or do they just put it on a flat screen?
Well, they just kind of like put it on the flat screen.
They put it on the flat screen. So they're still going to have to deal with this problem. Even if they're internally storing it as the sphere, we're still going to run into this problem. If you want to know how to get from here to Sydney, Australia, we're going to have to deal with this problem. So ideas. What does Google Maps do?
Well, at certain distances and altitudes, when you look at the Earth like forward, there's no curvature.
Right.
So do they take like certain blocks almost and represent those as two-dimensional?
Exactly. Exactly. So what we've already seen is, the Earth is really big, and at least sort of locally, if we were to go outside and look around in sort of this 500-foot, maybe 1,000-foot area, the Earth looks to be really flat. Okay? So what Google Maps probably does, again, the word probably, is they're going to divide up the surface of the Earth into lots of small regions, where within that particular region, the map might actually be really good, where distances are basically preserved and angles are preserved, because we can basically approximate that small part of the surface as just a 2D plane. Okay? And so they can have lots and lots and lots of these things built up. So then we get to the question, now that we know how do we describe maps? How do we store maps? How do we process maps? How did Google Maps actually build this big database? What were some of the tools that it used? Okay, so we've certainly got a few things up here. Did Google Maps use satellites to construct this? Sure. We'll talk about that a bit in a bit more detail here momentarily. But satellite imagery was definitely a tool that they used for getting quite a good perspective of what's going on all around the Earth. Some of you have probably seen, maybe in New York City, other major areas, you've seen these Google streetcars driving around that sort of have the weird paint job and this massive circular weird thing floating around on top of it. You've seen it driving around?
I think one drove this one about a couple of weeks ago.
Yeah, I think one probably did come through. They sort of go back. Why might they come back through an area that they've already mapped once? To update it. Do things change? Yep. Geography doesn't usually change on the same frequency as the internet, but it still changes. Roads are built, roads are closed. Earthquakes destroy roads or bridges. Not a good thing, but it happens. Okay? But so maybe they have these cars with these cameras that go through and actually drive through the roads and collect a whole bunch of information. Another way that Google might use it is through, or build this map, is through user input. Has anybody ever looked down at the bottom? So you see here's the little street view icon. You can look, there's a couple different images, whether you want satellite or whatnot. And has anybody ever noticed next to the scale, there's this little button that says send feedback? Anybody ever noticed that on Google Maps? Has anybody ever actually done it? Okay, neither have I. I've never found their map to be wrong. I'm not going to waste their time by just saying, hey, great job. But there's that option. If you find you're going out and you find that a map is wrong, or maybe there's construction has demolished the road and they haven't caught it yet, you can send that feedback. And someone at Google will look into it and say, oh, wow, the map has changed. We should update that. Okay? But that's another option. So there's some sort of crowdsourcing going on here where it's sort of giving you the option as the user of this, if you find something wrong, please tell us. It's kind of neat. Something more recently, this is an article I found last week. Who thinks you can use sheep to make Google Maps? Okay, well, obviously the answer is probably yes, because would I put it here if the answer were no? There was a remote part up in the Faroe Islands, basically up in Scandinavia, between Norway and Iceland, where there's basically no roads, there's these steep hills, and so to try to get information on what was going on, they actually put the street view cameras on sheep and had them just roam through the island. It sounds out of this world, and it turns out the maps weren't actually all that great. They had to go and do a bunch of image processing and cleaning them up. But I thought it was sort of funny where, you think about that camera being mounted on a car, that makes sense, but you can mount it on sheep and it works just fine too. What was that? Or the sheep just falls over. Yeah, that's a possibility too. Poor sheep. But anyway, I would encourage you to read through this. I thought it was just sort of a funny article. But again, the idea is there's lots of different tools that are being used to make and build all of these maps. Okay? So we have all of these different resources, whether it's satellite imagery, the street view, or from the cars, from sheep, from user feedback. And the question now is, once Google collects all this information, can there be errors? Sure. Okay. So one of the things that happens, just like with the internet, is there's someone at Google when all of this information comes in. So here's this big dump of... Lost the microphone. Can still hear me okay? Okay. So there's this big dump of satellite information. Is there someone at Google sitting there looking at every one of those satellite images saying, there's a road, there's a road, there's a road, there's a road, and coding all of that in to give some sort of representation that then makes a searchable database? Is someone actually sitting there doing that? And why not? Number one, that's a huge amount of data. And number two, is anyone really that bored that they would honestly be willing to be paid to sit there and do that for probably years on end? I don't know. If you're getting paid $1 million a year, you might put up with it. But then again, I'm still not entirely sure. I might do it for a week at that pay scale, even to be like, no, this is just so boring, I need to do something else. Okay? But the point being is, there's no person sitting there doing this. This is just, it's a Herculean task. Okay? And so what they're doing is they're using computers. And so I know some of you probably wrote about, in some ways in your term paper, like computer vision, or maybe if you did biometrics, you might be having this in there, where they're going to take now these image files from satellites, put them through some sort of algorithm to try to pick out where are the roads, where are the paths, where are these roads, are they residential roads, are they main roads, are they interstate highways or expressways? Because is that different distinctions that Google Maps would want to know about? Yeah, when it's making its directions, it's usually going to try to put you on a high speed limit road rather than a low speed limit road with a whole bunch of stop signs. Unless, of course, you explicitly tell it, I want the absolute shortest path. Has anyone ever clicked that button before? You can go in and sort of, there's advanced options. You can say, find the shortest path, just in terms of mileage. Does it ever really put you on main roads if you do that? Oh, it's almost always residential streets, because there's so many more of them, and you can actually just try to find what is that actual shortest distance. But the downside is if you compare how long it takes you to get from point A to point B, sometimes it's a factor of 2 or a factor of 3 longer, because you're stuck doing 25 miles an hour, stopping every 1,000 feet for a stop sign. Okay? But it's something that's in there. And so Google Maps is going to want to distinguish then, what's the 25 mile an hour residential road, what's the 45 mile an hour main road, what's the 75 mile an hour 347. No one does 55 on 347. Just seriously. Okay. And so we have to distinguish all of this, and we've got these algorithms. Are those algorithms perfect? Probably not. So what we've got here, and this is one of the pictures from that Atlantic article that I mentioned a little while ago, is some area. Memory has me assuming this is somewhere in Maryland, but don't quote me on that, and it doesn't really matter. But where they've gone through, and we can see there's a whole bunch of roads here, and they've had their computer imaging go through and try to identify what are the different roads, and there's some color coding that goes on here. So, maybe this big red line here in the middle, notice there's not really a lot around that. Looks like a wider road. Maybe that's an interstate or some sort of expressway. And so they've got that colored in red. And does that red line do a pretty good job of hitting that road? Yeah, it's not bad. Okay, so maybe now all of these blue lines that come through here are sort of either just main thoroughfares or maybe even residential roads, but there's something that's not quite a highway. And so notice maybe down in this region, do they do a pretty good job of finding the roads? Yeah. Here there's some problems, so it sort of looks like that blue line. I don't know if you can see it on the projector here, but it's sort of driving through a tree. Maybe you can see it. If not, take a look at the notes when I post them after class and see. It's not perfect. If you notice right here, so there's this blue line coming right there. Does that actually go through the intersection? No, it actually sort of nips the intersection a little bit and tries to take a bit of a shortcut, which I'm sure if you're the driver, you're going to appreciate that 3 seconds of saving. But if you own this house right there, and there's this, Google's now telling someone to drive through your house, you're probably not going to be quite as enamored with that shortcut. Other areas, notice there's sort of this little roundabout up here in the top left corner. Did Google Maps even get close to getting that roundabout right? No. So there can be lots of errors that creep in, even though this is a pretty good satellite imagery, and the fact that we did pretty well overall, okay? There can be errors. How do we go about fixing those errors? What might you do? We could use Siri, yes.
So if they're recognizing them based off of parameters, it means that sometimes you might have to manipulate the parameters. Like if you notice that it's not getting curved roads, right, you have to put in something that'll account for curved roads.
Right. So maybe one of these, so there's this computer vision algorithm. There were some parameters and some knob twisting that went into that to sort of do thresholds of when you get a highway, when you get a curved road, et cetera. Maybe we need to tune our parameters a little bit better and run this stuff through. That's perfectly plausible. Are there other ways? And so let's assume we've already done that, and these are the best parameters we've come up with, and this is the map that we get. Okay. So certainly we could always try to develop, are there better algorithms for doing this? But suppose we've got a good one, we're happy with it. Are there other ways we could go about trying to fix some of this information? I don't know. So we've used satellite map. Have we used our sheep yet? Okay, so there probably weren't sheep in this suburban Maryland area. But, have we used any information from our cars yet? If we had our Google Maps car sort of driving around, would that car know that we missed this intersection down here if it tried to drive through there? Yeah, because did that car drive through someone's house? No. Most of the Google Street cars still have a person actually driving it. Of course, if it was an automated car, it might have. Let's assume it didn't. Okay, so Google would see there's a disparity in that information. From the satellite information, we're getting this information, which sort of misses that intersection. But when we look at what our car actually did, they don't quite line up. Okay, so we can combine several of these sources. This is one of the reasons why Google has so many ways to construct the maps, is it helps improve accuracy. If we notice that there's a disparity between two of these methods, that's something someone should go look into. And so if we only have to look into some sort of finite number of areas, is that something now a person could conceivably go in and try to fix? Yeah. And so maybe there's someone at Google now, the automated procedures say, oh, it looks like there's a trouble region here, please go look at it. Person then goes in, oh, this is easy to fix, sort of drags this blue line back up, hits the intersection, moves on to the next issue. Or likewise, maybe someone sent feedback saying, you know, your Google Maps tried to have me drive through someone's pool, I doubt they appreciate that. Please fix it. Okay, so they go in and they fix it. And so after combining all of these different resources, what they might get is something that looks much more detailed. Again, this coming from the Atlantic article, where again, we've got sort of in the red line, this highway. Notice now that it's actually split, and most highways are divided, right? Where there's sort of the one distinct set of lanes for going, in this case, let's say westbound, and another set of lanes dedicated to going eastbound. And notice that we actually get those two lines here designated this is a separated highway. That's the level of detail we were able to get when we combined all of these sources. I know it's hard to see on the projector here, but take a look at the notes later when you get home, that you'll actually see there's sort of little arrow signs in here even indicating which direction those lanes are going. Is that important information if Google's going to want to give you directions? Yeah. Are you going to follow Google Maps if it tells you to go the wrong way on an expressway? I hope not. Okay, that would be a problem. So there's the joke. There's this woman's watching the traffic report on TV, and they come in and say everyone who's driving on the interstate needs to be really careful. There's one car driving the wrong way on the highway, and it's a major traffic risk. She's thinking, wait a second, my husband's driving on the highway around time. I should call him and let him know. So she calls him and says, "Hun, be careful. There's someone driving the wrong way on the highway." And he goes, "One, there's hundreds." Okay. He's the one driving the wrong way. But be careful. And so what we can do is also sort of notice now, when they've done this, so now look, and you see some of these roads are actually shaded in green rather than blue. So maybe green is more like that 45-mile-an-hour, more main road. The blue is still residential. But now notice, did we get this sort of curve right up here where we were missing it before? Yeah. Our little roundabout up here in the top left corner. It's good. One other area we didn't point out on the last slide, there's what I'm presuming is this landfill here sort of on the top, and there's these little paths that you could drive, sort of going up and down the landfill. Did the satellite imagery even pick those out? No, there's sort of no line or anything superimposed on there, versus when they combine this information, apparently the landfill let the Google Street car go drive through the landfill. Sure, whatever. But you can actually see that it was able to pick out those routes as well to tell you if you wanted to know how to get to the top of the landfill. I'm sure that's a search term you're using frequently in Google. If someone does it in the next 2 days, come tell us about it on Wednesday. Okay, but the idea we can combine all of these sources and actually get now quite accurate maps that both tell us sort of where the roads are going, are there directionalities associated with the roads, and what type of roads are they. And that's all really important information if we're going to try to recommend routes to people. Okay, so is that all we can do with this huge amount of data where we're getting satellite information, streetcar cameras, user feedback, sheep? Or are there other things we can also get out of all of that information? Okay, so again, coming from the Wired magazine, especially with like the Google Street cameras, those cameras are not just looking to see what's on the road, but they're also capturing as it drives by everything on the side of the road. And so, again, we can put all of this imagery through some sort of computer vision or computer imaging software and try to figure out and extract, could we get business names and logos to know that, oh, look, there's a KFC or a Wendy's or an Applebee's or, I don't know, pick some other kitschy chain restaurant that you like. Chick-fil-A, done. Okay? Maybe we can pick those out, and we can put that into our information and into our database to say, oh, well, now we know there's a Chick-fil-A on 347. Okay? Is that something that maybe we would like to do while we're going and doing all this processing? Sure. One of the other things we can do is those cameras are going to pick up the street name and information boards to help us feed in. What road are we on? What are these cross streets? As then a way to sort of calibrate that all of these different sources are working together and giving us the right information. The street camera can actually pick up some of these road symbols on the pavement to try to help us figure out how many lanes is the road. So when you're driving in Google and you've got the Google Maps and it's giving you directions, and it says, be in either of the left 2 lanes to turn left at the next light, because it knows both of those lanes, well, from your perspective, allow you to turn left. If it was just satellite imagery, would you necessarily have that level of detail? No, all it would do is say turn left at the next light. Okay? But we can pick that information up. We can also see that maybe there were minor roads that we missed. So thinking back to the search engine unit, the Google Streetcar in this imaging says, oh, here's something the next time we go through with a car, we should go back and get that. We didn't know there was a road there. We should add that to our queue and make sure we get that included the next time we have a car going through the area. Could also get traffic restrictions. Maybe this is how we learn it's a one-way road, or that there's no left turn here. Again, if Google Maps tells you turn left here and you see there's this big fat no left turn $300 fine sign, are you going to want to make that left turn? I mean, realistically, you're going to look around, nope, I don't see a cop, and then you're going to do it anyway. But should Google Maps really be recommending that to you? Probably not. And so through these streetcars, it can start to pick out what are these other traffic regulations, which have nothing to do with the road layout, but are very important to know when we're actually out driving. Okay? And so again, this is why we have all of these different types and these different resources for information, because when we combine all of them, it gives us a much better picture of what's going on these roads. And so finally, we can, as we've already sort of said, use all of that data. And so you can see here's a whole bunch of those street signs. This is a particularly awful intersection in San Francisco. And start to see that we've got, pedestrian and bike path warnings. We've got different roads, some horrible exchange, different interstate numbers, caution signs where maybe there's a curve coming, you need to be careful and slow down. But this is all stuff Google Maps can put into its database to help give you the best directions when you're out driving in real time. And I think that's pretty cool. Okay, so any questions on sort of this discussion on how Google Maps was built or all these different resources? Like I said, I really encourage you to go take a look at these articles. They're well written, and there's a lot of neat pictures like this buried in them.
So did they go through and blur every single license plate in Street View?
Do they go in and blur every single license plate in Street View? Again, I'm guessing there's a computer software that'll just do it. The license plates are probably pretty easy to pick out and just do it automatically. I doubt there's a person sitting there blurring every one of them out. On the other hand, if you put your credit card number on the back of the car, they will only blur that out after they take it. Okay, so other questions? All right, so now at the end of this whole procedure, we've now got a way to describe maps and build this and describe all of this geographical information and to catalog it. So what do? Naturally, we search it. And as we've sort of said several times, we can look up places, we can get directions, and we can do lots of other things. So maybe our driving question is how do we determine now the best route between two places? Okay? And this is going to be sort of the theme as we go through this last unit, both in terms of how Google Maps works, and then also when we come around to next week, looking at how do we take this same idea and try to think about the internet, of how do we get messages and data from one place to the other through this massive network of different computers. But we'll save that question for a little while in the future. Before we do this, though, a few other sort of contextual comments to make on Google Maps is, are there other things besides just directions and whatnot that we either would like Google Maps to have or that we've come to expect from Google Maps? Okay, so I'll put a list of things here of things that I've thought of, and we can discuss these. But before we go through that, does anybody have other features that maybe we haven't discussed or things that you would like to have of Google Maps or that you've come to expect from Google Maps that we haven't already mentioned? Okay, well, certainly one thing, sort of as point one, do we want Google Maps to work on our mobile devices and not just our computers? Yeah, because that's what makes it useful when you're in your car, because do you take your wired computer with you in the car when you drive? Not usually. It doesn't work so well. Okay? So by being on our mobile phone, that allows us to actually get this real-time information as we're driving, and sort of, again, in-your-face MapQuest. But that's certainly something we want, and at this point, we know it's there. We've just come to expect it. That's why MapQuest isn't a thing anymore. Okay, sort of as point two, and we'll talk about some of these points in more detail on the few next slides. You know, as a sub-point of one, do we want even Google Maps to work on our cell phones and our mobile devices without a cell reception or without Wi-Fi? Yeah. Okay. It turns out that's a bit of a complicated problem. We'll talk about that more in a minute. Do we want Google Maps to update in real time for traffic or construction or other issues like that? Yeah, that'd be nice. If suddenly we're on 347 and an accident occurs 2 miles up ahead, if Google can say, hey, turn right and go down to the next road, you're going to be better off. That'd be awesome. And in fact, Google Maps does that. Is anybody driving sort of on a long car trip and suddenly Google Maps changes your route midstream? It's happened to me before. That's what it's doing. Would we like Google Maps to try to take into account weather or other emergencies? Yeah. And so in particular, what's one example of this? Again, sort of something in sort of recent news. When there was all the flooding in Florida due to Irma or in Texas due to Hurricane Harvey a few months ago, Google Maps had actually teamed up with a lot of the emergency providers in those states to try to tell people as they're driving around either Florida or Texas which roads are open, which roads are closed. And you could actually see Google Maps updating as we have the cat playing with the laser pointer. And there's, of course, Mr. Chad Myers talking about this. But you know, they were updating Google Maps in real time to try to tell you which roads were flooded versus which ones were still passable to help people try to get either the emergency responders how to get someplace where they were needed, or if you were trying to evacuate at the 13th hour, after the hurricane hits, it's not the 11th hour anymore. How might you be able to get out? Okay, but is that something we would like to have Google Maps doing? Sure. Okay, so that was one thing. We all know it can do this, but do we want Google Maps to take into account public transit routes and schedules? Maybe you don't want to drive everywhere. Maybe you want to walk. Is that maybe a different set of directions if you're walking than if you're driving? Yeah. Are there one-way sidewalks? Not generally. I mean, I'm sure there's some place in the world where someone has said this is a one-way sidewalk. And if it's in America, everyone probably just ignores it. But do we care about all the one-way road restrictions or the no left turn here if we're just walking? No, so that changes how we might give directions. If we know there's public transit options available, is it good to know those as alternatives rather than having to drive or walk? Yeah, and we know at this point that trains and buses and all that are included, as it turns out, in Google Maps. And that's kind of neat. Maybe 6 goes without saying here, but Google Maps should be low in errors and or pranks. Would it be good if it was full of pranks? Yes, it would. Okay, so we have someone who doesn't really care about getting from point A to B, but wants to laugh at it. And the reason for this, so a few years ago, someone hacked into Google Maps and in some place in rural India said there was some sort of farm, I believe, that had a particular shape. This is no longer there. This was reported to Google about 2 hours after it was hacked in. Google then promptly removed it, put out an apology, and what did they then do? They cracked down on who has access to their maps. So before this, it was a lot easier if you could register with Google to be like sort of a third-party developer to help them with their maps, and they would basically give you full access. Yeah, that doesn't happen anymore. You can still get that level of recognition from them, but there's a lot more hoops you now have to jump through because of this delightful little incident. But okay, so there could be pranks. Google tries to prevent them, but you know, where there's a will, there's a way, and that was not a challenge to you. But okay, so it'd be good to make sure that it's sort of low in pranks. And what do you think? Number 7, should Google Maps be fun? Okay, should Google Maps be fun? Oh, this one you're indifferent about. Okay, so maybe it should be. And one of the neat things, so I think a lot of you know sort of every April Fool's Day, Google usually does something sort of hee-hee, ha-ha, slapstick funny on their website. 2 years ago in 2015, they did one thing, and then they actually resurrected it this year, which was fun because this lecture fell right around April Fool's Day last semester, where they actually turned Google Maps into Pac-Man. Did anybody see this? last April. So you could actually go and it would take all of the sort of streets and make them these Pac-Man tunnels. And they put the little dots around there and they would put ghosts on the map and you could just sort of run around and play Pac-Man on some weird street layout. And so there were actually the different challenges that people had issues of sort of what were the most fun places in the world to play Pac-Man on Google Maps, like where were the roads the craziest. I think sort of like the old city of Rome was a good one because none of the streets are straight, none of them are parallel, it all goes nuts. Chicago, it turns out, is really boring. Everything's just sort of nice and on a grid. Manhattan is really boring. Downtown Manhattan, like the actual financial district might be okay, but sort of like Midtown, really boring. And so there's this Wired article, again, the link there of sort of the top 15 spots people found you can sort of sort through here. What was that? Okay. Okay, so yeah, so they made a label this is San Francisco, where there's a big hill here that you wouldn't necessarily see on the map, but that's why it's so curved, is it's so steep. That's just how they had to do it to make it accessible. The sort of weird thing for me, and this is completely unrelated to anything important, when this came out in 2015, you can Google around, you can Google to find more information about this, and there was a little bit more of sort of what was the math that went into this. It completely surprised me to find out there were two people that were responsible for basically making this program and putting it all together. One was a professor of math at one of the universities in Washington. The other one was a software developer for Google. They were both in my 5th grade class, which was sort of, these were names I hadn't thought about in 20 years, and also I'm like, wow, they've done something. That's kind of cool. They made Google Maps turn into Pac-Man. Awesome. Just sort of as the weird aside. Even though they were people that I didn't really even like that much. It was sort of neat to see that they did cool things. Okay, so there's a whole bunch of things. Other ideas that you might have on things we may want out of Google Maps. Okay, so number one on the list is sort of just a programming exercise. We're not going to have a whole lot more to say on that. Some of these are just sort of fun, but let's talk about some of them. So working without a cell signal. Does Google Maps work without a cell phone reception or without Wi-Fi? Yeah, it does. Okay, so what are some of the limitations of that? Why does Google Maps typically need cell reception or Wi-Fi to work? Well, so they can recalculate if you're using it for directions. In principle, this is an algorithm that could probably run on your phone in some cases. This is what we'll talk about on Wednesday, is how this actually works. More to the point, though, how much memory or hard disk space does your phone have? Maybe a couple gigabytes? Maybe? Well, compared to a computer, so a computer maybe has, let's even say you've got a really good hard disk. Your computer's got 1 terabyte of disk space. How much space do you think the entire Google Maps geographic database requires? Probably more than a terabyte. Probably more than several thousand terabytes. This is a huge database. So is that all going to fit on your phone? No. Well, that's useful. So why do we need this signal? As you're driving around, it's going to say, well, here's this area that I'm now entering. I need that map to be able to do this. And so it uses either your cell signal or Wi-Fi if you're just connected on some sort of internet network to go to Google and say, send me this particular map. Remember, Google Maps is probably subdivided into all of these local regions just that we get this fidelity with angles and distances. And to say, here's the one I now need and that I'm now using. If you don't have cell or Wi-Fi connection, is it going to be able to do that? Not necessarily. So what you can do is Google Maps does have a mode. You can say, I'm going to work offline and say, go preload while you're at an internet or a Wi-Fi or cell reception. Go ahead and preload these set of maps because I know I'm going to need them. And then you can function with them offline. There's a limit to how many you can download based on how much memory your device has. Fine. But you can do that. Only since 2015, and late 2015, so it's only been about 2 years now, can Google Maps fully function without a cell signal or Wi-Fi or having to preload the maps. How are they making that work? What other type of communication system does your phone have today? Think back to the beginning of the semester. It has GPS. Is that, in some sense, a communication network? Yeah, you're communicating with these satellites floating up there. And so what Google Maps was able to do in certain ways was to actually process the information to get it to go through the GPS network, where in addition to sending just the signals to say what's your timing and your location, they can actually piggyback data onto that as well. It turns out it's really expensive. But since the end of 2015, if you're going to be traveling in an area where you know cell service is light, there's not really a lot of internet, you can go and authorize your phone to do Google Maps over the GPS network. Again, it's going to cost a lot. That's not what GPS was designed for, but it's something you can do. And there's some more information here in the article at the bottom of the page. But that's something that's a possibility. How does Google Maps know about traffic? Oh, question.
How does, like, when you have, like, no service, like, with the iPhone, like, if I go from no service area, like, it'll give me the directions and my location.
Okay, so what ends up happening in that case is when you turned on Google Maps in the beginning, you probably did have some service because you were probably at home sitting in your car or here or there where there was cell signal or internet. And it automatically knows when you boot it up, it'll say, bring me the local map that I'm on, and it'll store that. And so long as you don't leave that region, it'll work just fine. And I don't know exactly what the sizes are on the regions, but I imagine it's probably 10 miles by 10 miles or something like that. And so as long as you stay in that grid, it will work just fine because that whole thing will be downloaded onto your phone. But if you're going to do a longer trip where now you need to leave that region and you didn't have the cell or the Wi-Fi reception, you would run into problems as soon as you sort of literally fall off the end of the map. That make sense? Okay. Other questions? Okay. So then how does Google Maps know about traffic? The joke, it seems unlikely that they've got a car stuck at every traffic jam. So we've all seen on Google, it'll give the directions and it shows, here's the blue part, here's the orange part, here's the red part. Avoid the red part. How does Google Maps know that information? Okay, so maybe it's using satellites to then say, look at, oh, there's a whole bunch of cars backing up here. That could potentially work, but I think it's unlikely because there's probably some sort of time delay on the satellite information that they get. Just for security and privacy reasons. The road information doesn't change that quickly. So conceivably that could work, but I don't think that's necessarily how it's being done. But it's a good thought. Other ideas?
Probably have someone driving around, or they use those traffic cameras.
Okay, so they might have a car actually sitting in traffic. Again, plausible, but maybe not as complete as we would like. Maybe they're using traffic cameras. That could work in areas where there are, but not all parts of the United States have embraced traffic cameras. So that could be a big limitation. Yeah. Everyone travels with this. You've all got your cell phones on you. And those cell phones are communicating with Google Maps when you've got the application open, looking for directions, downloading new maps. And to do that, it has to know your location. And so can Google then track your phone? I know this is sort of creepy from a Big Brother perspective. Can it track your phone to determine how quickly you're moving along these paths? And if it sees now there's a whole bunch of cell phones that aren't moving at this one point in the road, what might it infer from that information? There's a traffic jam. Yay, Big Brother.
I've noticed that, like, if I'm driving and it has, like, the red in it,
Mm-hmm.
but there's no traffic there anymore, it'll disappear.
Right, so then some traffic goes through and it's noticing that all of a sudden people's cars are going through and then it updates its information to say, oh, there's not a jam here anymore. I think it would be a fun project, not something we will do, if we had a big class like this and we all just went on the side of Nichols Road and just turned on Google Maps and put our phone on the side of the road and to see if it would then trigger a traffic jam on Google Maps. I have no idea if that would actually work or what the number of cell phones you would need is, but it's a fun thought question. Okay. And so this goes back to sort of the idea of GPS, where they can then use sort of the cell signals, they can use this location information on your phone, and all of that trilateration back from GPS to figure out where are you and monitor how quickly are you moving around, and then use that to get traffic information. And again, there's some more information on these links on the bottom of the slide, which then sort of brings us to maybe our last slide for today, just to come back and think about this, our driving question. How do we determine the best route between two places now? So we've got this big geographic database. We want to search it. And so two of the questions, I'll leave these as open questions today, and we'll certainly discuss more about them next time. How do we describe our map mathematically? What are all of our places and what are all of our paths? How do we turn that into something we can work with? And then once we've got that done, how do we define best? When we say what is the best route between two places, what do we mean by best? So think about those two questions in the next 2 days. Remember that we've got a quiz on Wednesday, and your term paper is due also on Wednesday. Have a delightful afternoon. Stay warm, and I'll see you in 46.5 hours.